integrated rate equation. For each of order, we have different formula for integrated rate equation. For zero order, the equation is A naught minus A equals to KT. First order, ln A naught over A equals to KT, and second order is 1 over A minus 1 over A naught equals to KT, where concentration of A naught is actually concentration of the reactant at initial. The initial concentration of the reactant. Concentration of A is actually concentration of the reactant remained or left, yang tinggal at time T. Okay, concentration of the reactant that left at time T. K, we have learned earlier that K is the rate constant. And T is the time. Unit of the time can be in any unit, and it depends on the rate constant. Let's try this example. The decomposition of SO2Cl2 is a first order reaction. This reaction has a rate constant value of 2.2 times 10 to the power of negative 5 per second. Okay, look at the unit given. The unit given is per time. So if the unit of K is per time, so confirm it is first order reaction. If the reaction begins with 0.05 mole of SO2Cl2 in a 2-liter vessel, determine the concentration of SO2Cl2 after 30 minutes. So we can use, now we have to use the integrated rate equation. Since it is first order, so we have to use the formula for first order, that is ln A naught over A. But now, since the reactant is not A, the reactant is SO2Cl2, so we have to write the reactant. Okay, the correct species is SO2Cl2, not A, ln SO2Cl2 not over concentration of SO2Cl2 equals to KT. So this is the integrated rate equation for first order. Okay, so to calculate concentration, initial concentration of SO2Cl2, given is the number of mole and also the volume. So number of mole is 0.05 mole, divide with volume is 2 liter, so we will get 0.025 molar. Then we can calculate ln 0.025 molar over concentration of SO2Cl2 after 30 minutes, so equals to K is given 2.2 times 10 to the power of negative 5 per second. The unit is per second, and the time given is 30 minutes. But now the constant is in unit second, so we have to convert the unit to seconds. Okay, minutes you convert to second, then after you calculate, you will get concentration of the reactant, that is SO2Cl2, after 30 minutes is actually 0.024 molar. That is the answer for A. Now let's calculate for B. How long does it take for the concentration of the reactant to drop to 30% of its initial value? How long means the question is asking for time. And now the reactant drops to 30% of its initial value. You have to be very careful with the word, sometimes drop to and sometimes is drop by. Okay, drop to and drop by is different meaning. For example, my weight is 100 kilogram and it drops to katalah my weight drops to 40 kilograms. From 100 drops to 40 kilograms. But okay, if my weight, firstly my weight is 100 kilograms and then it drops by it drops by 40 kilogram. So if it drops by 40 kilograms, meaning that now my final weight is 60 kilogram. So you have to be very careful with the word used. Okay, so how long it takes means we have to calculate the time. Okay, now let's calculate the reactant after it drops to 30%. So 30% times the initial concentration, 0.025 molar is actually 7.5 times exponent negative 3 molar. Okay, then you write the integrated rate equation, concentration of SO2 Cl2 not over concentration of SO2 Cl2 equals to KT ln initial concentration is 0.025 molar, concentration of SO2 Cl2 it drops to 30%, means now we have to write drops to 30%, berkurang kepada, bukan berkurang sebanyak, berkurang kepada. So 7.5 exponent negative 3 molar and equals to 2.2 times 10 to the power of negative 5 times with T. Then after you calculate, you will get the time is 54726.037 seconds. Okay, the unit is second. Why the unit is second? How do you know? Because from the rate constant. So that is the final answer.